In a revelation that has stunned astronomers and sparked a global wave of fascination, NASA's James Webb Space Telescope has detected something completely unexpected: faint, rhythmic beams of light coming from the dark side of a planet orbiting our closest stellar neighbor, Proxima Centauri. The discovery immediately set the scientific community abuzz. These mysterious emissions weren't random flares or the result of some known stellar phenomenon. They resembled something eerily familiar to us: the signature glow of artificial lights, like those cast by cities across Earth during the night. And the implications of that are nothing short of staggering. Proxima Centauri b, the planet in question, orbits a red dwarf star just 4.24 light-years from Earth. It has long been of interest to scientists because it lies within the habitable zone, the narrow region around a star where liquid water could exist on a planet's surface. It's a rocky, Earth-sized planet that receives just enough warmth to suggest it might not be the frozen wasteland or scorched inferno that many exoplanets turn out to be. But until now, no one expected it to give off light, especially not from its dark side, the hemisphere permanently turned away from its sun due to tidal locking. That's what makes this discovery so electrifying. When the James Webb Telescope, with its unmatched infrared sensitivity, focused on Proxima Centauri b, researchers expected to find the usual indicators of planetary behavior: variations in temperature, perhaps signs of atmospheric composition. But instead, they detected a subtle yet unmistakable light signature coming from the planet's night side. It wasn't a glow from reflected starlight, nor was it thermal radiation. The spectrum of the light had narrow bandwidth characteristics, something natural planetary bodies don't emit. On Earth, this kind of light pattern is associated with artificial sources like LED or fluorescent lights. The idea that we might be seeing the glow of alien cities is exhilarating and terrifying. Imagine standing on the surface of Proxima Centauri b. Above, a red sun hangs low and dim. One hemisphere of the planet remains in perpetual daylight, while the other is locked in endless night. And somewhere in that darkness, clusters of organized, structured light glimmer softly, like distant urban skylines. Could this be a civilization harnessing its planet's energy, illuminating the dark with technology we might one day understand? Skeptics urge caution, of course. Science demands rigor. There could be natural explanations we haven't considered. Some theorize that strange atmospheric reactions, unknown types of auroras, or geological phenomena could produce these emissions. Others propose the possibility of a highly reflective mineral on the surface creating a feedback loop of light, although such hypotheses struggle to explain the regularity and spectral purity of the signal. But the timing, intensity, and recurrence of the light continue to defy conventional reasoning. It's not just a one-time flicker. The light pulses in intervals, as if it's responding to something or serving a purpose. Adding to the intrigue is the fact that the light was detected consistently during multiple observation windows, eliminating the likelihood of a data error or temporary anomaly. Scientists used time-resolved spectroscopy to confirm the light wasn't a result of instrument noise or interference from the host star. It was coming from the planet itself, from the side that should have been cloaked in darkness. If this is artificial, it changes everything. We wouldn't just be looking at evidence of life. We'd be witnessing proof of intelligent life. More than that, it would mean that intelligent life exists not in some distant galaxy billions of light-years away, but right next door in cosmic terms. Proxima Centauri b is, by interstellar standards, a stone's throw away. With the right propulsion technology, it's a destination that could one day be reached. Scientists have now begun deploying additional methods to analyze the planet's atmosphere. By studying how light filters through the upper layers, they hope to identify chemical markers associated with life, water vapor, methane, carbon dioxide, and potentially ozone. If even a few of these indicators are present, it would support the hypothesis that the planet is not only habitable, but perhaps even inhabited. But the real key is to detect signs of industrial activity. Chemicals that don't occur naturally in large quantities, like chlorofluorocarbons, CFCs, which on Earth are a direct byproduct of human industry. If we find those, then the mystery becomes much harder to dismiss. This discovery also shines a spotlight on the power and precision of the James Webb Space Telescope. With its massive mirror and ability to observe in the infrared spectrum, it has opened a window into the previously unseen corners of the cosmos. It has allowed us not just to observe galaxies forming at the edge of time, but to examine the atmospheres and surface temperatures of planets tens of trillions of kilometers away. And now, possibly, it has glimpsed the glow of an alien civilization. The debate has already begun. Some scientists are cautious, calling for months, if not years, of peer-reviewed study before any conclusions are drawn. Others are more daring, proposing that we begin formulating a response strategy. Should we send a signal back? Should we listen more closely to Proxima Centauri's radio frequencies, hoping to catch a reply? Or should we remain silent, as some suggest, for fear of alerting a civilization that may not have peaceful intentions? The truth is, we don't yet know what's out there, or who. But for the first time, we may be able to see the evidence with our own instruments. The larger implications of this discovery are hard to overstate. If the lights are real and artificial, they confirm that humanity is not alone. The philosophical and cultural impact would be immense. Religions would reinterpret their doctrines. Governments would reshape their policies. Space exploration would shift into overdrive, not merely to explore, but to connect, to prepare, and possibly to defend. Even our understanding of ourselves would transform. We'd no longer be the lone intelligent species navigating a cold and empty universe. We'd be neighbors. This also raises questions about the path of technological evolution. If Proxima Centauri b hosts intelligent beings, how old is their civilization? Are they ahead of us or behind? Do they use light as we do, for work, safety, and communication? Could their cities be solar-powered, their buildings glittering in alien architectures unknown to earthly eyes? Or is what we're seeing the remnants of a past civilization, lights that still burn, automated and abandoned, long after their creators vanished? More data is being gathered even now. The European Southern Observatory, NASA, and other global observatories are coordinating to verify and expand upon Webb's findings. They are also preparing instruments like the Extremely Large Telescope, ELT, which will soon be able to image exoplanets with even greater resolution. With it, scientists hope to peer deeper into the night of Proxima Centauri b, perhaps even resolving surface features and climate patterns. Until then, we watch and wait. The James Webb Space Telescope has reminded us that the universe is alive with mystery, and that sometimes, the most profound discoveries come not from loud explosions or flashing stars, but from faint, steady lights twinkling on the far side of a distant world. Whether they are natural or artificial, those lights are now a beacon of curiosity for humanity. They are a symbol of how far we've come, and how far we have yet to go. Here at Discovery at 2.0, we will continue following this story as it unfolds, bringing you the latest insights, the most exciting theories, and the wonder that comes from knowing the universe still has secrets to share. If these lights are the echoes of another world, then we may be closer than ever to answering the age-old question, are we truly alone? And if we're not, what comes next?